Hello again. Welcome to week 6. This week we're going to continue our discussion of data production methodology. And we'll take what we talked about last week in terms of file design, structured file management, and combine it with some of the life cycle principles we learned previously. And certainly technology is going to play a part in this week's exercise. But we're going to combine those in the development of a specific workflow for managing structured data, which is the most common single task that an information manager has to accomplish, certainly in the area of digital information management. And when we talk about structured data, on its face, it's kind of a misnomer. One assumes that if data is in a usable form, it is somehow structured or organized against a specific set of rules or standards. What we're referring to is data that's really in process from being raw data that was just captured or collected and moving it into a form where it can be translated into usable information by human beings. So, as information managers, whatever work environment we're in, we're going to be called upon at various times in our career, some of us more than others, but we'll all face it at some point, where we have to take some sort of raw information, format it, process it, manipulate it so that it can be ingested into a data management computer application, and then it can be presented out to end users who will perform queries and retrieve it and extract report information of some form from it. So the main tools that there's three sort of main classes of structured text and the tools that go with them. Certainly the first one, which is the sort of oldest and most widely used form of structured text, is the plain text document, which has specific formatting and structuring rules applied to data elements that are saved inside the plain text document. The very oldest one format is the comma-separated variable format of document. There are also tab-separated variable and several other different variations, but a CSV file is essentially data that has the bare minimum structural elements so that primarily another computer application can ingest and read that information and manage it. CSV style text documents are not generally meant for human consumption. They're meant for information applications to consume and use. Another very popular and widely used form of structured text document is XML, and the whole family of markup languages, going back to the original markup language, which was SGML, or Standard General Markup Language. And then moving on to HTML, which is actually a form of presentation language that was designed to create presentable information on the web, of course. And SGML also spawned the development of the extended markup language, XML, which was originally designed by consortia of industry, major industry members, including Microsoft and Apple, I believe. Oracle and IBM had representatives there. And XML was not really intended originally for use on the World Wide Web. It was intended as a data transfer language that applications could use to communicate data with each other and then actually manipulate hierarchically structured data within them and so forth. But XML really has sort of taken on its widest form of popularity on the World Wide Web as a data source container for various dynamic data that has to be pulled out of a database and formatted into a structured, recognizable format and then presented through a web page. There are other proprietary formats of structured text which are really tied to a specific type of application, such as the markup languages, which are XML based, but markup languages for geographical information systems, for various scientific disciplines, for various industry purposes, for various library purposes. So, for example, in the library world, a very common form of XML implementation is a format called EAD, which is the Encoded Archival Description format. And that was developed by the Library of Congress, I think around 10 years ago, for the storage and then interpretation and presentation of archival finding aids or archival resource directories. XML is extremely popular. We'll maybe talk about this a little further in the lecture too, but it's extremely popular and it'll probably stay that way, but in a number of areas it'll get supplanted by other technologies and other standards sometime probably in the next 10 years. But right now it's extremely useful to understand XML, and we'll talk more about that. The second class of structured data in the form of data sheets or spreadsheets, which are documents meant for handling data in complex table structures. We've all had to use Excel documents or an Excel variant like the OpenOffice spreadsheet or some other version of spreadsheet. Datasheet tools are extremely useful for manipulating data before they are moved into a database storage environment. And also, scientists find the use of Excel for data analysis and interpretation, as well as collection and formatting, to be very popular. In fact, if you become a research data manager, probably the single most common format of data container that you're going to run into in your career is going to be Excel spreadsheets. They're extremely popular in the scientific community, both for social and natural sciences. And then the third class of structured data tools are databases, which are complex systems for managing data that has relational characteristics, I guess would be the best way to say that. The earliest kind of database actually wasn't relational, but it was more akin to a formatted kind of spreadsheet, but that is called a flat file database. And you only see those around nowadays for either very simple purpose applications or for legacy applications. The FileMaker Pro was a very popular database, desktop database application for many years, and it was completely flat file, which meant it was essentially a big spreadsheet with an interface on top of it. That was before version 7 of FileMaker Pro. Current versions of that product are much more relational in characteristic. Structured query language database platforms are probably the most single popular and are going to remain so into the foreseeable future. The term SQL or SQL You'll hear it referred to as both, depending on what industry area that the person you're talking to comes from. But SQL is a standard, an ISO standard that was developed actually in the 60s for performing database operations on complex data sets with a very simplified, what they referred to back then as an English, natural language, English type query language. Actually, SQL is easy to master with some practice, but it's nothing like speaking plain English. But the most common commercial platforms that are in existence right now include Microsoft's SQL Server, the Oracle database format. IBM has a SQL database that they continue to sell called DB2. And then there are a number of open source database formats. MySQL is one, PostgreSQL is another. Both of those are excellent tools and they're both free. The others that I just mentioned earlier are all commercial applications, and with the exception of some sort of freebie, lightweight databases that each of those vendors offer, you do have to pay a significant licensing fee to use their product. There is actually also, at least for MySQL, an enterprise edition of that database, which is meant for commercial application that there is a fee for. But the desktop versions of MySQL and PostgreSQL are free, and they can actually be used to manage fairly good-sized websites, which is frequently where they are implemented. The other commercial database applications are generally implemented for other types of business purposes, customer databases, financial databases, personal information records databases, government databases, etc. Now, as I mentioned before, XML is very popular for application in web settings. There was a time when XML was first being developed that it was thought that XML technology might overtake the SQL database technology, and that never really happened. But in its heyday, there was a specific form of XML-style database that was developed, which were really mainly designed as big containers to manage collections of XML documents within. As I mentioned, I think earlier on the last page, the family of structured markup languages such as XML, HTML, and SGML were really devised for managing documents, and they are formulated on the concept of a document premise. So rather than SQL databases, which are formulated on the premise of a record structure, so you have tables in SQL databases, and each table has columns and rows like a spreadsheet. XML structures data differently. It's structured in a hierarchical format. And there are some specialized variants of the hierarchical format database that you may run into. But XML-style databases, or doc bases, since they manage collections of documents, are not really widely used, and they probably won't become any more broadly used in the future. In fact, we probably will see their decline in the next 10 years. There is one notable implementation of an XML doc base here at UNM, which you can check out. It is the Rocky Mountain Online Archive, which is an implementation of the EAD, Encoded Archival Description, that I mentioned previously. And the Rocky Mountain Online Archive is sort of medium-sized database of around 1,200 to 1,500, I think 1,600 documents, XML documents. And one of the reasons that XML is not, in terms of a database technology, is not going to be proliferating more in the future is that it turns out it's fairly tedious to write queries and transactional instructions for XML doc bases. You actually have to use an XML style sheet or an XSLT document. You actually have to write a document in order to perform a query on an XML database. So it's not as easy as the sort of script-based instructions you can write for a SQL database. There are also other specialized forms of database technology that you will hear about or run into. Another technology that, like the XML database technology, is probably not going to go anywhere, although it had its moment in the sun a few years ago. It's the object relational database, which is built on the whole concept of object-oriented programming. That format of database didn't really ever take off, but they are still around. And it's sort of speculated that there will be future database technologies that will either be based off of the SQL platform or maybe new variants of XML like the resource description format, RDF. So that's probably where you will see new types of database technology being developed in the next 10 years or so. Now, this workflow model here outlines how we're going to proceed to take a set of structured data from its raw state, plan how we're going to deal with it, capture the raw data, process it, mark our changes to the data, find out how best to retrieve the data and make it accessible to users, and then present it out to the world. We'll call this a data production workflow model. And for our purposes, it's a lower level model than, say, the information lifecycle model. This is really more of a step-by-step procedural model than the lifecycle model, which is a higher level conceptual idea. So let's go through each one of these steps just briefly and talk about them. Now, when I've had you writing up your information lifecycle models, that in a sense was a form of modeling or planning for information management needs. But the first step in the design of any workflow or lifecycle model is to determine what the information need is. So what do your users need out of the data that you will be collecting? The second step is to determine what acquisition sources you'll be obtaining the data from in its raw state and what methods you'll be using to collect that data. The lifecycle design does come into play in this part of the data production workflow, in that we'll be designing specific methods for transforming data into information and making it useful based on what section of the lifecycle model it's in. So whether it's in the creation phase, the active use phase, the semi-active use phase, the archiving phase, each one of those will have a comparable set of processes at the data management level. Certainly we need to, at the point where we're modeling what our data processing workflow is going to look like, we need to select hardware in the case of data collection tools, such as maybe sensors or input devices, and software, such as our database platform or what spreadsheet tools we'll be using. And then we need to define a concise series of procedural steps in how we're going to move the data from its raw state into its finished state. Second step in the data production workflow is the actual acquisition of data. Now, acquisition can mean several different things. It can mean acquiring raw data from some manual or automated source. That's typically in either research or industrial environments. Certainly the use of sensors or sociological surveys asked of research participants is a way to acquire specific raw data. Other forms of data aren't going to be so exotic. I mean, certainly a lot of us are simply going to be capturing metadata or information about other information that we'll use to manage a collection of documents, either forms or processing documents or library information resources. And then some data can be user-generated. Certainly, it can be, user-generated data can be collected automatically. Web usage data or library usage data is a good example of this. The major step in the data production life cycle is the processing phase, where we actually take the raw data and convert it into a usable form, which might involve several different steps and several different tools to get it into its final form, and also involves several different steps in cleaning and standardizing the data so that it can be easily understood by human users. So the first thing we'll probably have to do is convert the format of the data. If we're, for example, if we receive a comma-separated variable file of raw data, we would then want to import that into a spreadsheet application so we can clean it up. And then we might want to move that into a database application where we can maintain the data and users can access it. And there are a variety of import tools that we would use along the way from each step to convert the data. And the next three steps, cleanup, harmonization, and formatting, are all simply transformations that we apply to the data so that it is standardized and it's readable. Cleanup, we would want to correct any spelling or actually any data errors that on imports, such as maybe there are cells that were left empty that shouldn't have been left empty in the original data sheet that we collected the data from. Harmonization, especially if we're talking about taking data that was created by human beings, maybe such as surveys or written documents. Humans are particularly notable for not conforming to standardized forms of expression. So we may need to apply a controlled vocabulary. We may need to convert values. If somebody's noting a value in some records in our data set in hours, and other records, other people are referring to that same time format in days or years, then we'd want to convert all of those values into a common format. And to do this, we would use a variety of batch operations, search and replace, reformatting operations. And then finally, the cosmetic application of stylistic formatting to the data. Not style in terms of like what font we're using, but style in terms of what form is a title entered into in a series of data records. Are the dates all in the right format? Are the names all last name, comma, first name format, or are they mixed up? So we would use, again, a number of batch operations, and then probably also datasheet type of formulas that help us transform the data from into a final readable format. Whenever we have a data set that we're working with that we need to apply major transformations or changes or updates to, it's good to document that data. The documentation can either be captured in the form of internal notes. So for example, with a columnar set of data in a spreadsheet or a database, you might want to create a new column where you would capture notes about data formatting and changes and value conversions and so forth. We also want to note whether we made harmonization changes and actually changed the content of the data. So whereas if we're trying to collect a set of data about various cities and some of the data refers to towns and villages, then we would want to maybe correct those by making sure that all records refer to cities rather than hamlets, towns, villages, and metropolises, and so forth. So documentation is important. Whether you keep the documentation about the data changes you've made internally inside the actual data structure itself, or externally in the form of a report or a specification or even a README file about your data. It's important to mark what changes have been made just so people know that the raw data has been manipulated in some way to make it easier to understand. Once we have a clean set of data that's readable and understandable and all speaking in the same format, the next step we might need to apply, and this is not in every case, but we may need to determine what the best outputs for that data will be when we move to the presentation part, making the data readable for human beings. We may not want to make, in fact, perhaps all of the data accessible at one time to our end users. Maybe we just want a subset of that data. Maybe we need to figure out which fields would be best to show things like totals and aggregate quantities for the data. So maybe we would need to do some testing on the data to see if we can get useful information out of grouping, totaling, sorting various columns in the data set. If we're dealing with research data at this point, we might also start applying some advanced statistical methods to it, regression analysis and so forth. And also, if we're going to design the data set so that it can be queried, such as a large database that we want people to be able to search against against thousands of records, and that you can't report the entire set of data easily to everybody, we would need to determine what would be the best access points or retrieval or query fields for that information. So if it's a set of library data, do we want users to be able to query against the title, authors, the date? Do we really need them to query against publisher? In the case of office-based information, such as in a government or a business office, you might be looking at case data or customer order data that you would need to be able to search on some of those data elements, like customer name and product ordered, or case number and case applicant. But you wouldn't need to to necessarily be able to report or query on all of the fields in that data set. So in the analysis and retrieval phase, we're simply looking at what points we want to publish and what points we want to make searchable against our data set. Once we've made sort of the intellectual decision about what we want to retrieve and display in our data, that's the time when you would build query objects or query scripts so that they would actually enable a database application or even a spreadsheet application to provide data retrieval, and data filtering. Desktop databases such as Microsoft Access or the OpenOffice database allow you to create data query objects, and in fact a number of different types of database applications or spreadsheet applications do provide the means for creating and saving canned or reusable queries. And then there's also specific types of queries depending on your database application. So for example, a query that you might write that allows somebody to input values for what they're searching for, like title or author, is called a parameter query. And we'll talk about this more in the exercises. Specific types of queries that you might write for a computer application, on the other hand, are often called stored procedures, which are saved on a database server, and then a program actually triggers that procedure in order to query the database or update the database or some sort of database function like that. As I think I mentioned, XML document bases tend to make you write an actual XML document to perform a query against the database, but this is another way to save a query object. And SQL or SQL database commands can actually be written into script files or text files that are can contain one or many sets of commands all at once and can be executed just like a small application program to perform a specific data retrieval and manipulation functions. Once we've actually created our query inputs and our output fields for our data set, then we can attach the data set to some sort of presentation tool. Now, in the case of a desktop database, presentation tools might include query forms, where you actually have a user go to a form in the database and input a query and run it, and then it will retrieve a set of data. Reports in the form of pure document type reports are another. Some reports are more integrated into other kinds of applications, such as dashboards and web pages that tell you how many people have used a particular product or how many people on the site have ordered a particular item. So with that brief summary of the data management workflow process, let's start talking about our major project, which we're actually going to take 2 weeks to do. And there'll be a number of different parts that you need to complete for this assignment. And then I'm also going to provide some specific demonstration videos for you along the way. So our data management project is going to have each of you take a raw set of data, convert it into a data sheet format where you're going to apply batch operations and formulas to format the data and prepare it for import into a desktop database application. And for that application, you will write some output forms and reports. Now, the project is going to be due October 7th by midnight, and I'll create an assignment section on WebCT under week 6 for you to turn the assignment pieces in, which I'll tell you about in a minute. I'd like everybody to use OpenOffice 3 for this. The application is free. You may have already downloaded it for one of the other earlier assignments. And specifically, we're going to be using the spreadsheet and the database OpenOffice applications for this purpose. I'm going to provide demo videos for each part of the assignment to show you some examples of how to do the major steps in the assignment. So make sure you watch all of those before you proceed with each separate part. The first section we'll call data processing, and actually the assignment isn't going to require you to go through all 6 steps of the data workflow model. I'm actually going to provide some raw data in a structured text format for you, and I'd like you to take that data file, import it into the OpenOffice spreadsheet, format it according to the instructions so that it is human readable and the formatting is all standardized. Then next, I'd like you to build a desktop database, and then we'll move the datasheet contents into the database. And then the next step will be to build some queries to support reports and query forms. And then finally, I want you to output the data in a finished report form that is human readable and human consumable. And to turn in those 3 parts, a documented data sheet, desktop database, and final report document by Sunday, October 7th at midnight. And certainly if you have questions along the way, feel free to email or call me at any point. Like I said, I'll be posting video demos for each part of the assignment along the way, and there'll be more detailed instructions posted online for you. So with that, let me know if you have questions or comments, and if not, then have a great week. Bye.